Hi Cashew Nation, I'm Engineer JD, a structural engineer and a review and college instructor, and today we will talk about normal distribution. So let's get started. In this video, we will talk about the concepts behind the normal distribution and the standard normal distribution and how it is implemented in the Casio FX 570ES Plus 2nd edition. And then we will present an example on how to calculate normal distributions using this calculator. Normal distribution occur frequently in nature. It is also occurring in many engineering applications. For example, in transportation, we model the flow of traffic using normal distribution. Also, the strengths of concrete and steel, we also model it using normal distribution. Now, the formula for the normal distribution, we have this probability density function right here, which requires three parameters: the value of x, the mean mu, and the standard deviation sigma. Now, this is a probability density function, meaning if we plug in any value of x here, we will always get 0 as the probability. Now, to calculate actual probabilities here, we have to use ranges like A and B. Now, to calculate the probability that a random interval, a random variable, x lies between A and B, we will get the integral of this function. Now, we also have what we call the standard normal distribution, which is this formula. Now, this formula was obtained by taking mean equals 0 and standard deviation equals 1. And to convert any non-normal, any non-zero mean normal distribution to a zero mean normal distribution, we will use what we call the z-score, which is this formula: z equals to x minus mu over sigma. This converts a normal distribution into a standard normal distribution. And for the calculation of probabilities, it's still the same. We get the integral. Now, in the calculator, we have these three options. We have P, Q, and R, representing three different areas given a variable t. Now, P represents the probability that the given value of z is less than t. Q is the probability that the given value z is between 0 and t, and R is the probability that a given value of z is greater than t. In the calculator, we can access this function using mode and then 3 and then 1. For the single variable statistics mode, we will be presented with this. And once we press AC, we can now press Shift and 1 to access the 6 options here. Now, for the distribution, for the normal distribution, we will use 5. And then we will be presented with 4 more options: the P, the Q, and the R as presented in the picture. And then this arrow T, this is what I mentioned earlier, the conversion of non-normal to non-zero mean normal to zero mean normal distribution using z-score. This is number 4. Now, let's apply this concept in an example. We have this compressive test of 45 concrete cylinder samples, which revealed that the 28-day compressive strength follows a normal distribution with mean 27.6 megapascals and standard deviation of 6 megapascals. A concrete sample is considered acceptable if its strength is at least 38.8 megapascals. First, what is the probability that a concrete sample selected at random is not acceptable? Now, to do that, let's press AC first. Now, we are now inside the single variable stat mode, or to access it, again, we press mode 3 and then 1 for the single variable mode. Next, let's input the first two rows. First, with mean plus standard deviation. So first we have the mean. The mean is 27.6 and then the standard deviation is 6. Let's add it to the mean, plus 6. That's the first row. And then for the second row, we subtract the standard deviation from the mean. We have 27.6 minus 6. We have this. Then let's press AC and let's access the statistics options. Shift 1 and then 5 for the distribution, and then let's choose between these 4. Now, the problem says that we require the probability that a certain sample is not acceptable, meaning its strength shall be less than 38.8 megapascals. Since it is a less than, we will use the P function. Let's press 1. And then let's input 38.8. This is our criteria, 38.8. And then let's convert this 38.8 into a z-score using Shift 1 and then 5 and then 4. and then let's close, and then we can press equals. We have now 0.96903, and therefore the probability that a complete sample selected at random is not acceptable is 0.969 or 96.9%. Oh, that's high number. Now next, for the number 2, how many of the 45 tested samples is not acceptable? Now this is easy. We have now the calculated probability of not acceptable samples. All we need to do is to multiply it by the number of samples, which is 45. Let's multiply it by 45 and then press equals. That is 43.606. We can round that up to 44. That's a very large number of samples. 44 of the 45 are considered not acceptable. Now, for the third problem, on the average, what percent of the test samples has strengths above 30 megapascals? Again, press AC and then shift stat or 1 and then 5 for the distribution. Now, since we require strengths above or greater than 30 megapascals, we will use R or the right function R. Let's input 30, and then let's convert it again to a z-score using shift 1 and then 5 and then 4 and then close parenthesis. Now this is in decimals, so to output the result in percent, let's multiply by 100 and then let's press equals. Now the answer is 34.458%. 34.46% of the samples has strengths above 30 megapascals. And that's it for our today's lecture about normal distribution. I hope you learned something from here. See you on the next video and thank you very much.